So we're going to look at reciprocal graphs today. I'm not going to do all the steps because they're very, very similar in technique to the quadratics and cubics you've been drawing. So you have an equation, substitute some values in, outcome coordinates. You can use the table as a shortcut. If you do that, you will find one value a bit peculiar. I'm going to do that one by hand. What happens here if x is 2? Well, we're going to use this equation up here. So we're going to get y equals 3 divided by x, which is 2, take 2. Well, we know what 2 take 2 is, that's nothing. So we're doing 3 divided by 0. And at this point, some of you should have some alarm bells ringing, because 3 divided by 0 is not part of mathematics. Dividing by 0 is not maths. So this is some kind of alarming error. So if 2 is using this function, we do not get a coordinate out, it breaks it. That's important, okay? If 2 goes into this function, it breaks it, because dividing by 0 is not part of mathematics. Or certainly not standard mathematics. So, I've already worked out the coordinates using the shortcut, and I've already pre-plotted them. So when you get to this point, you see that the coordinates are all over the shop. It looks a bit peculiar. We have these coordinates over here, and these coordinates over here. And what a lot of people try to do is they try to join this set to that set. But look at where these things happen. This value here is 2, where it breaks. So we know there's no function there. So we know that there isn't any graph here because 2 is where it breaks. So this curve goes through these points nicely, and that's all reasonable and good. And these points have a curve that goes through them, and that's all reasonable and good. Okay, so we get these two curves that are completely disconnected. There is a discontinuity in this curve. So what happens between this value at 1 and this value at 3? Well, we know that in between it breaks. But if I use this on some different settings, so rather we start at 1 and we go up to 3 let's go up in 0.2s, in smaller increments. So we've already got 1, negative 3. 1.2 is 3 3/4, so this is already up here. 1.4 is already up at 5, down at negative 5 rather. 1.6 is all the way down at 7.5. 5, 6 is all the way down here, and we very quickly zoom off the bottom of the page. But we never get flat again. It just gets steeper and 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 steeper off the bottom of the page. We can do the same thing over here with the positive values. So we can just about fit 5 on at 2.6, which is there. You can get that value on, and at 2.8 it's 3 3/4, which is there, pretty accurate. So that goes through there. So these curves shoot off to infinity, and then they shoot back on from infinity, but they do not join up. Okay, this is a peculiar shape. You need to recognise it. It has a proper name. It's called a hyperbola. And technically it's one curve, but it does have a gap in the middle. An infinitely small gap where it breaks because you can't put some values in. It's not always 2, it's only 2 in this case because this fraction had an x take 2 on the bottom. Whatever gives you 0 here is what breaks it. So I hope that clarifies how to draw these. The key thing is do not join these up. They are separate curves when you draw them. Alright? Separate curves when you draw them. Have fun with it.